Welcome to the educational research section of www.happynumbers.com. Today's video is going to deal with a descriptive statistic called the standard deviation. The standard deviation. We have been talking about measures of central tendency when we're looking at distributions, how the distribution tends to center around some numbers. And we've been talking about measures of spread. Measures of spread. And the standard deviation is a measure of spread. It is the measure of spread or range of a distribution that is used when the mean is the measure of central tendency, but we'll get into that. Some prior knowledge. You should have a good grasp of the concepts of computing the mean and median and their strengths and limitations. And there is a video on the website. I think it's called Measures of Central Tendency or Measures of Center, and you might want to look at that if you're not clear on these concepts before you look at this. Okay, well, let's get an overview of it. So we've been talking about now the standard deviation is a measure of spread. When we were working with the median, these two measures, the range, which is the largest number minus the smallest number, and it uses all of the data, that's one measure of spread when the measure of central tendency is the median. And then the interquartile range, which is covers the middle 50% of a data set. And again, that is used when the median is the measure of central tendency. Now the standard deviation, which is used when the mean is the measure of central tendency, quantifies in a very, very different way. The standard deviation looks at every data point in the data set and measures how far that point is from the mean, how far each observation is from the mean of the data set. And then it gives the average or typical distance of every data point from the mean. Remember, this X bar is how we denote the mean. Now, there are many notations for the standard deviation. You may see SD, you may see S, you may see S small d, you may see standard D, the abbreviation. But for the sake of this video, we're going to use the capital SD to denote the standard deviation. Well, I'm going to show you how the standard deviation is calculated, but don't worry about calculating it. I want to try and get the concept across. The concept, so you won't have to calculate standard deviation. Okay, we have a data set that represents the number of customers who entered a video store in 8 consecutive hours. So the first hour, 7 customers came in. The second hour, 9 customers. The third hour, 5. The next hour, 13, then 3, then 11, then 15, and then 9. So we'd like to get the standard deviation of this data set. Well, here is the data set right here. I put it there. And if we total it up, there was a total of 72 customers that came in. Now, if we take the mean, if we want to know the mean number of customers that came in, well, we have to add up all the scores and divide by the number of scores, and there are 7 scores. So we add them all up and divide by 7, and we wind up with the mean is 9. So the mean, or the average number of customers per hour, was 9. Now, to compute the standard deviation, remember I said it's the distance of each score from the mean. So now we have to compute the score minus the mean. So let's what that looks like. Here the score is 7 and the mean is 9. So 7 minus 9 gives us a -2. Here the mean is 9. 9 minus 9 would give us 0. Here the mean is 5. So 5 minus 9 gives us a -4. Here the mean is 13 minus 9 gives us +4. 3 minus 9 gives us a -6. 11 minus 9 gives us 2. 15 minus 9 gives us 6. And 9 minus 9 gives us 0. Well, okay, so we've taken the distance of each score from the mean. And remember, the standard deviation is the average of the distance of each score from the mean. Well, if I were going to average these up, if I added all of these up, they will equal 0. And in fact, any computation of the standard deviation, that will be so. The difference between each score and the mean, if you add them up, will equal 0. So that doesn't really help us because I have negative numbers and positive numbers. But if I take each score minus the mean and then I square them, what happens is, if I square negative 2, because 7 minus 9 gave me negative 2, negative 2 times negative 2 gives me positive 4, because a negative and a negative is a positive. And so if I go on down, now 0 times 0 gives me 0. But I have negative 4, so negative 4 times negative 4 gives me 16, and 4 times 4 gives me 16, and so on. 2 times 2, negative 6 times negative 6 gives me 36. 2 times 2 gives me 4. 6 times 6 gives me 36, and 0 times 0 gives me 0. So all I did was I took the score, the difference between the score and the mean, and I squared it. So this way I got rid of all of the negative numbers. Now, since the standard deviation is the average of all scores from the mean, I have to add this up, and I get 112, and I have to take the mean, so I divide by 7 and I get 16. Now, this 16 is not the standard deviation. It's a concept called the variance. It is the average deviation of each score from the mean. Now, since I squared these numbers, I'm at a different unit of measurement. I'm in squared, like square inches, because I've squared something. Well, there's no concept of square customers. So to get the standard deviation, I take this variance, the number 16, which was the average of the squared differences of the scores and the mean, and I take the square root. So the standard deviation is the square root of the variance. In this case, the standard deviation here is 4. And the reason we took the square root is when we squared these numbers, we then were a different unit of measurement. We were working in square, like square inches or square feet or square yards or square customers, but there's no such thing as a square customer. So we had to bring it back to the initial level that we were at. Okay, so I don't mean this to be confusing. I just wanted to give you a basic idea of how the standard deviation is computed. You certainly will not have to do this. Computers, software does this for you. But the standard deviation is very important, so let's take a look here. Properties of the standard deviation. The standard deviation should be paired as a measure of spread when the mean is the center, the measure of the center. And the standard deviation, like the mean, is greatly influenced by extreme scores. We use the mean and standard deviation as a measure of center and spread only when our distribution is reasonably symmetric and has no outliers. So we use this with distributions that approach the normal distribution looking. If it's a skewed or uneven distribution, we do not use the mean and standard deviation. If it is skewed or otherwise, we use the 5-number summary, which gives us the median and interquartile range, and box plots. Okay, now, here is a sort of normal distribution, sort of bell-shaped normal distribution, so it would be appropriate to use the mean and the standard deviation as the measures of center and spread. And here's the thing about the standard deviation. If you have a symmetric mound-shaped distribution, like a bell curve, then approximately 68% of observations in the data set will fall within one standard deviation unit from the mean. So about 68% of all the observations will fall between plus 1 standard deviation and minus 1 standard deviation. Here would be the mean right here, and this would be plus 1 standard deviation unit, and this would be minus 1 standard deviation. 95% of all of the observations will fall between plus 2 standard deviation and minus 2 standard deviation. So almost the entire distribution will fall within the plus to minus 2 standard deviations. And approximately 99% of the data points in the distribution will fall between plus 3 standard deviations and minus 3 standard deviations from the mean. Let's take a look at some applications of that. Here we have a data set. It's the height from 50 males, and the data set is fairly normal. Here is the actual data set right here at the bottom, and the mean of this data set is 70.58, and the standard deviation is 2.85. Well, there are 34 observations between positive 1 standard deviation and negative 1 standard deviation. If you added them up, like this is 3.5, and this is 4.5, and this is 4, and this is 7 and 7. So if you added up these, you would get 34 observations. Now there's a total. We started out with the whole group was 50. So 34 divided by 50 times 100 gives me 68%. And the standard deviation rule says that about 68% will fall between positive 1 standard deviation and negative 1 standard deviation. So you'll see this fits the rule. Let's look at 2 standard deviations. Well, if you added up all of this, we would get 48 observations, and we have started out with a sample of 50, so 48 divided by 50 times 100 gives me 96% of all the data points fall between -2 and +2 standard deviations, and the standard deviation rule says it should be about 95%. So we're very, very close here, and all the observations fall between -3 and +3 standard deviations, and therefore 100% of the observations fall between the -3 and +3 standard deviations, and the standard deviation rule says about 99.7% should fall there. So you can see that this rule applies very, very well to this distribution, even though it's not perfectly symmetrical. So that's the significance of the standard deviation. In special ed, one of the ways they used to qualify students for special education is if they were below 2 standard deviations from the mean. If they were below 2 standard deviations from the mean. Well, let's take a look at some practical examples. The length of human pregnancy in days. So the length of pregnancy is not fixed. It varies according to a distribution that is pretty much normal, roughly normal. Sort of looks like this. And we can use the standard deviation rule to answer some questions. Now, the mean of this distribution, the average number of days for pregnancies is 266, and the standard deviation is 16 days. 16 days. Let's take a look at question 1. How long do the middle 95% of pregnancies last? Well, if we look down here, we know that 95% of the data points will fall between +2 standard deviations and -2 standard deviations. So that would be +2 would be 298 days, -2 standard deviations would be 232 days, because our mean is 266. So Two standard deviation units would be 298 minus 234, and that gives us 64. So how long do the middle 95% of pregnancies last? Anywhere between 234 and 298. Next question. What percent of pregnancies last more than 298 days? Okay, well, 298 days is 2 standard deviations above the mean. And we know that 95% fall between negative 2 standard deviations and positive 2 standard deviations. So if 95% fall between negative 2 standard deviations and positive 2 standard deviations, that means 5% are not included. And if we divide 5% in half, we get 2.5. So 2.5 are between positive 2 standard deviations and positive 3 standard deviations, and 2.5% fall between negative 2 standard deviations and negative 3 standard deviations. So we took 95% fall between positive 2 and negative 2 and said 5% is left over, and so we split it in half and put 2.5 then fall between positive 2 and positive 3 standard deviations, and 2.5 fall between negative 2 and negative 3 standard deviations. So half of the 5% is 2.5. So 2.5% last longer than 298 days. So 2.5% of pregnancies last longer than 298 days. Take a look at another question. How short are the shortest 2.5 of the pregnancies? Well, the 2.5 is here between negative 2 standard deviations and negative 3 standard deviations. So the shortest, they last less than 234 days, because that would be negative 2 standard deviations, and so that area is here. Last question. What percent of human pregnancies last more than 266 days? Well, 266 days is here. It's the mean. So it says what percent, and the mean divides the distribution in half, 50%. So 50% of all of the observations fall above the mean. I'm sorry that. So from here to here, that would be 50% of all the observations. So to answer the question, 50% will fall above the mean. All right, let's summarize this. So the standard deviation measures spread in a distribution, and the distribution needs to be sort of normal, by reporting the typical average distance data points are from the mean. It's an appropriate statistic of spread when the mean is used as the measure of the center. The mean and the standard deviation are influenced by extreme observations or outliers. And for symmetric mound-shaped distributions, the standard deviation rule is in effect, which says, pardon me, that 68% of all of the data points will fall between positive and negative 1 standard deviation from the mean, that 95% will fall between positive 2 and negative 2 standard deviations from the mean, and that almost 100% of the observations will fall between positive 3 and negative 3 standard deviations from the mean. Well, thank you very much. That's the standard deviation, or a measure of spread. And again, that's used when the mean is the measure of central tendency. Thank you, and we'll see you next time.